This is an overview of how to create compensation matrices from single-stain controls in OMIC. I'm here in a dataset that has 7 files. The first 6 are single-stain controls for different colors in this experiment, and the last file here is an actual sample that we want to be able to analyze after correcting for compensation. To get started, what I'll do is create a new workflow. Once that workflow is created in OMIC, we'll see that we've gotten the default structure of what that workflow should be according to what the files are, and etc. In this case, if we open up the compensation task that's already here, we'll see that it's a blank compensation. Whatever you see here is going to be based on what is present in the FCS metadata from the time of upload. So if you didn't do any compensation at the instrument or close to the acquisition time, you'll see a blank matrix like this. You might also see a rudimentary or more precise set of values here if you did some amount of compensation at the instrument. Okay, in either case, we'll basically follow the same workflow from here to create our own new compensation from single stain controls. So we'll go back to the workflow. And the key thing that we want to remember is that we want to leave out compensation as part of the workflow when we're creating compensation. The reasons for that should be pretty self-explanatory. But to go ahead and do that, what we'll do is go back up to the workflow root, and we'll create a task which will serve as a new branch, and we'll choose scales. Okay. A conversation on scaling is out of scope for this workflow, but of course we have some other discussions of that within our documentation. If you needed to set scaling, you could set it right now. Otherwise, we're just going to continue on. The next thing that we want to do is simply go from scaling to creating a compensation matrix using this wizard here. So go ahead and click on that. Once we're taken into this interface, you'll see that we have something similar to the gating interface, but now we have this wizard that appears on the right to walk us through how to actually create a compensation matrix. To get started on the process, what we'll do is first decide which channels we need to select for compensation. This will just be based on which ones you have single stain controls for. So we'll select these 6 that we already alluded to. When we submit that, we'll get on to the next step, which is choosing our positive and negative control files from the files available in this dataset. At this step, what OMIC is doing is it's trying to look at your parameter names and look at your file names for the controls and figure out how they're supposed to align just based on naming conventions. But this process won't always be perfect. You might see a success message here in which OMIC thinks that it found all the correct matches, or you might see a warning that some of them still need to be matched. Regardless of which you see, you should definitely double check what happened automatically here. When we open up this page, we'll see a set of, first of all, the channel that's being compensated in the first column. We'll then have the negative file and the positive file as options to select. You can see here that all these were assigned correctly, except for pack blue, which in this case is because the actual parameter name for pack blue, or sorry, the sample name is a bit cryptic, just PB. Okay, so we'll, in this case, just select that sample there, and then we'll be done. There's other situations where you might have a common negative control, something like that, in which case there's some options here to, for example, click on this button, and then you can apply the values in a particular column to all of the other values present. So for example, if we click this button to apply this value, we would set all of the negative controls to a common file. Now that's not what we're doing in this case, so I'm going to cancel and come back here, and I'll have to reselect this now, but just for demonstration purposes. Okay, so once we submit this, we will have achieved the success message for step 2, which brings us on to step 3. The process for step 3 is to generate the gates for the positive and negative controls and then set their position appropriately. So to get started, what we'll do is, given the configuration information that we've just set, we'll now click this button to generate the gates. And you can see that on the left, we will now be displaying this collection of positive and negative gates for each parameter. And what we recommend is just go through top to bottom, or perhaps in some other order if you wish, and click on each one, and that'll bring up the actual area where you can see that gate, it'll also automatically select the control file. And then you can just go ahead and move these gates into position based on what you think they need to be. And then we'll click on the next pair. You can click on either pair from the sample or either gate from that pair, and then we can set them appropriately. On to the next, and so on. And you'll notice that each time the correct sample is automatically being selected. If it helps, at this point what you can also do is select a different plot type. Keep in mind that this selection will be temporary. The minute you go to some other plot type again, it will try to force it to a histogram. Okay, and then we're moving on to the last one, setting this appropriately. And that's all we need to do. The last step here is fairly straightforward. Now that we have our gates in position, all we need to do is actually just calculate the compensation matrix. And so that will be done by clicking on this button, and a compensation matrix will be produced for us. This can be done multiple times. So for example, if you decide you wanted to tweak something here and then generate it again, you'd see the change slightly reflected. Okay, now this compensation matrix is not permanent. For example, if we were to exit out of this task and come back, it won't have been saved, but all of the gate positions will be saved. Okay, so all we need to do is generate it again, and we'll get the same matrix once again. Now, how do we actually apply this matrix? Okay, this is where it comes to time to click this button, the copy matrix button. We'll then go back out to our workflow, and we'll just conveniently go to the branch of the workflow that's already waiting for us to actually insert that compensation. We'll go here. All we have to do is click on this paste button, and then we'll paste that compensation matrix in, and that's all we need to do. Once we save this, it will be applying to the rest of the workflow that we then can process here. If you were starting from a position where you didn't have a blank compensation matrix, so I can replicate that pretty easily, what you could do is create a new compensation manually, and we can choose which files we want in it. In this case, whether or not I choose the single stain controls is up to me, essentially. It could be nice to see how they're actually compensated. Choosing the parameters actually doesn't matter in this case, so we'll just choose a couple parameters that will end up being overwritten. And again, we'll just come in, click on paste. Once we paste that in, we'll be overwriting the compensation matrix. Let's consider some other situations that we should know about with respect to creating the compensation matrix. Here, as was demonstrated, there was no cleanup gates applied to these control files before generating the positive and negative control gates. That was simply a matter of keeping the initial demonstration simple, but now we can see that there's probably some cleanup we want to do first. So with that in mind, what we'll do is go to the parameters on which we want to apply a cleanup gate. I'll just use the forward scatter versus side scatter in this case, and just draw some simplistic gate. We'll call it cleanup. And of course, we may need to set this in different locations per file, in which case we would right click on it, turn per file position mode on, and then set it to exactly where we need to do it. But I'm just trying to skip through. I won't demonstrate that in very much detail. Now, the main message here is that there's principally two ways to go about using this cleanup gate. The first is that you can generate your gates and then move them to be children of the cleanup gate. Now, right now, this is a little bit tedious. What it consists of is right-clicking on each gate, cutting it, and pasting it to the new parent. And you can see that when you're doing this, when you cut it, OMIC will complain that it looks like there's some certain gates missing. And then once you paste it, the complaint will go away and you'll be all set. And then when you generate that compensation matrix again, it'll be using the gates partially from the root of the tree and partially from the cleanup. And you'd just have to continue moving these gates across. At some point in the future, there'll be a way to multi-select and cut multiple and paste multiple at the same time. So keep an eye out for that. But as of the time of filming, that ability doesn't exist. Which brings me to the next point, which is you should probably just set your cleanup gate before you actually go through and set your positive and negative gates. Once you've done that, so we'll set a cleanup gate and we can double click on it to activate it. Or as you know, you can right click on the population and activate it there. Or you can go up to the list of populations and activate it there. Once it's activated and you click the Generate Gates button, all the gates will be generated as a child of that cleanup gate. If you had multiple cleanup gates in succession, maybe you're going to do live dead or multiple forms of singlet identification, the same rule applies. You simply activate the parent that you want to generate the positive and negative control gates after. You click the Generate Gates button, and it will generate the gates. But the reason that you want to set this up ahead of time is because we're going to have to go through and reset the positions of those gates if we didn't cut and paste them. Every time they're generated from scratch, they will in fact be generated from scratch. Once you go through, as was demonstrated, you just click on Generate Compensation Matrix, and then it will generate the compensation matrix using the new control gates. There's another related situation to this. In more rare circumstances where you might need to put a cleanup gate on different parameters depending on the file of interest. So here my control files are all basically the same bead files, right? But there might be situations where you have to clean them up differently. And if you have different parameters per file, what you need to do is select the file of interest. Perhaps in this case, we need to clean up on just forward scatter width versus area, just choosing a random example here. We'll draw the cleanup gate on this parameter. We'll call this cleanup 2. And from here, we actually don't have a choice but to first generate our positive and negative gates, and then we have to cut and paste them across. And you'll do that just based on your own knowledge of which gates should be on which populations. Again, the same caveat where at some point you'll be able to do this in batch by multi-selection, but for now it's one at a time. And again, when it comes time to generate the compensation matrix, just make sure to re-click to generate it again. We'll then copy it, move back out to applying it, and we'll apply it. From this point, now that we have the compensation set, it's a matter of what we need to do next in our workflow to continue on with our task. Likely it would involve some matter of looking at the effect of the compensation, maybe tweaking it a little bit further, depending on if you do that as part of your workflow. But for those types of considerations, please see our other videos and documentation.